we talk about solar power, and that comes through a solar panel that harvests the sun, converts it into electricity. That has the power to drive a pump that draws out water and goes into a tank, and that can drive not only irrigation to really have really healthy crops. So a solar power pump has two specific elements. It's got solar panels and it's got the pump set, which can be driven either by AC or DC. The most important part of a solar power pump, it reduces electricity costs, or it prevents you from depending on the national grid, which in most African countries experiences power cuts. What does that mean in terms of MATLAB? All right, imagine that you manage to understand the solar intensity, which we talked about, right? Solar radiations, solar intensity, whereby you are able to predict what the solar intensity throughout a 24-hour day is. How would you do that in MATLAB? There are a couple of ways. One, you can collect the data, right? So you can, every day you might have a, I don't know, a thermometer, or you might have some other device that collects all the data. And with that data, you will be able to, hour one, hour two, hour three, collect all of that. Or you can anticipate what it should look like. And this is what this is trying to do. It's essentially, these two lines are what we call an array. So an array is essentially you basically discretizing time, in this case variable time, from 0 to 24 hours, 1 hours, which is when one of an hour is 6 minutes, right? An hour is 60 minutes, when one of an hour is 6 minutes. So this is a quite a fine way of discretizing time, right? So every 6 minutes you have a collection, and what you're trying to do with this time, this is very important. And for those who do not know why this is done this way, so if I were to type it here, what you get here is you get time, as you see, is an array of close to 241 elements, which means if I were to think about it, if you were to count 0 to 24 hours every 6 minutes, this is how many recordings you will have. You'll have 241 recordings. That's essentially what this is saying. So why is that important? Because it allows you to plot very finely the next most important part, which is defining the solar intensity. Now, this is quite important because the solar intensity here, how is it defined? It's defined, and we'll go through step by step, right? It's defined as a sine wave. Now, everybody knows what a sine wave is, right? So it's something that periodically changes, goes from positive to negative in a continuous waving manner. What this function basically does, it calculates the sine wave, right? And then multiplies it or scales it, as we call it in engineering, scales it by the time, and then shifts it by a specific number. There's a main reason for it, and we'll go through it. But the more important part is we know solar intensity is a positive number. So what this is doing is we have a max in front of it. Solar intensity cannot be negative, right? It's always either it's zero, right, which means at night it's not negative, or it's a positive number. This is what max does. So it says calculate the max between 0 and whatever this number is. So what does it do? And I'll put a breakpoint. This is important, right? When you want to do MATLAB and you want to understand what things are doing, you can use what we call a breakpoint, right? So you can run your script. So let me run the script and see what happens. And it says change to the folder. That's fine. I run the script and we'll see what the plot looks like. Now let's try and kind of zoom in into this portion right here. Can you see? And I want to also bring down a little bit here. Let me delete this. Okay, and delete this. All right. So what you see here is you see that you have a peak at 12. Can everybody see that? You have a peak at 12. And what that means is that essentially the intensity of the sun, if I were to double click, you will see that the intensity of the sun is 1, or the strongest. In this case, there's a unit called kilowatt per meter squared. But the most important thing about this is that at 12, this is the strongest. Now, this can shift between countries, right? And depending on the season, depending on which hemisphere you are, it can shift. But this is a really good approximation that at 12 o'clock at noon, you have a solar intensity that is the highest. Now, why do I need this? I need this, one, to show that from a plotting perspective, you can interrogate your function directly and you can also see whether it makes sense. Why does it make sense? Because you know that at 12 or around 12 is the highest, but you also know that there is darkness. And the darkness, there is no intensity, literally zero. Your solar panel doesn't work, right? I mean, solar panels are not meant to work during the dark. And that's what this is showing. In summary, you're able to have a function that predicts a common sense reading of what you would have collected on the field with a thermometer or some other device that directly in MATLAB you're able to plot, interrogate, and more importantly, we will now be able to save this variable solar intensity into a mat file that MATLAB recognizes directly and can read depending on what are the contents. This is the first part of this tutorial where we've shown what it means to have time vectors, what it means to have using trigonometric functions like sine to offset and to give some prediction of solar intensity. And more importantly, we looked at the plotting function that allows one to not only beautify but interrogate directly your data on a graphical element called a figure. And that figure and the data that goes with it can now be saved and can be used for the next step.